In this presentation, we're going to look at survival functions, which come up in both reliability analysis and actuarial science. So this is a sort of actuarial feel to it. The probability that the size of a randomly selected auto collision loss is greater than x is given as follows. This is the survival function s of x equals 1 minus x over 10 to the power of 6 for this range of values 0 less than x less than 10. Okay, now this is not any particular distribution specifically, so we're just going to take it as is. Calculate the mean and the variance of the loss size. Okay, now this is an important set of formulae here relating to survival functions. This is the key one. This is the crucial one. Okay, it's the kth moment, so to speak. Okay, so the expected value of t to the power of k is the integral of from 0 to infinity of k times t to the power of k minus 1 times the survival function s of t dt. Okay, so when k is equal to 1, we get that's the expected value of t, and the second moment expected value of t squared is the integral from 0 to infinity of 2t times the survival function s of t dt. In that case, k is equal to 2. Okay, so this is the fundamental formula here. Okay, now we'll derive it somewhere in another video because it's probably the type of thing that might come up as an exam question, just to derive that from first principles. But we'll just take it as is for the time being. That's the key one there, and these two here are essentially derived from it. Let k equal 1, let k equal 2, and we're going to use those there. So the expected value of x is the integral from 0 to infinity of s x dx. So that's that expression there. You might notice there that we update the limits of integration from 0 to 10. Okay, it's just that's what we're told in the question, so we can just do that. You know, just watch out for that. Now we're going to use u substitution here. Let u equals 1 minus x over 10. du dx is equal to minus 1 over 10, and consequently that means dx is equal to minus 10 times du. Okay, so that is what our integral becomes, minus 10. Essentially we just take the 10 out. Okay, the minus 10, take that out of the equation, and we get the integral of u to the power of 6 du. I actually could put in the limits there, but sometimes I just put them in at the end. I just think it's cleaner just to when you just sort it out. U to the power of 6, the integration of, when you integrate that, you get u to the power of 7 over 7. Just switch everything back and put in the limits 10 and 0. Okay, and so we get minus 10 times 1 minus x divided by 10 to the power of 7 divided by 7, and we're going to evaluate that at 10 and 0 and get the difference to find the definite integral. Okay, so we get minus 10 times 0 over 7 minus 1 over 7. Okay, the two minus signs cancel out. Okay, so they become essentially pluses. Okay, if you want, and that means the expected value is 10 over 7. Okay, same again, and what we're going to do here is calculate the expected value of x squared. Okay, just in this instance, what I'm going to do is essentially these two steps are just exactly what I've done previously. Okay, so I didn't even really need to write them again, I just had them ready. X is equal to 10 minus 10u, so 2x is equal to 20 minus 20u. Okay, so that's the 2x there, and that's the survival function down there. Okay, 20 minus 20u. Okay, that's 2x, and the survival function is u to the power of 6. Okay, so very similar to what I've done before. Actually, it's based on what I've done so far. It's just in a couple of additional steps. So take out the 20, we have minus 200, and we're left with 1 minus u times u to the power of 6, and obviously that's u to the power of 6 minus u to the power of 7. Okay, get the integral of that, du. Okay, so we end up with minus 200 times u to the power of 7 over 7 minus u to the power of 8 over 8. Putting in our values again, let u equal to, reverting to u equal to 1 minus x divided by 10, and using the limits of integration, we would get the following. Okay, so essentially in both cases we should end up with minus 1. I'm just sort of skipping that step there, or being very quick about it. When you evaluate it at 10, you should get 0. When you evaluate it at 0, you should get 1. So we should end up with minus 1 in both cases. So u to the power of 7 divided by 7 minus u to the power of 8 divided by 8. Sorry, when you evaluate that at, put that back at 10 and 0, and when you put in, u to the power of u is equal to 1 minus x to the power of 10. Sorry, I've been very glib about that. But anyway, it should end up as minus 200 times minus 1 over 7 plus 1 over 8, and that works out to be minus 1 over 56. So that's 200 over 56, okay, which is 25 over 7. Now, just for later on, I'm going to remark that that is equal to 175 divided by 49, okay. And so we're going to use what we've calculated there to calculate the variance. So the variance of x is equal to expected value of x squared, second moment, minus the expected value of x to be squared, which is the mean squared, 25 divided by 7 minus 10 over 7 squared. That works out to be 175 over 49, just as I remarked up there, minus 10 over 49, okay, and that ends up as 75 over 49, okay, so that's it there, that's it all done.